Okay, so continuing with the revisions, question 13 now. I know it's not clear, but I hope you can see. So we have 126 degrees here and 33 degrees here. Okay, I wish I can draw it, but anyway, it's like this. Then we have this, this, this. Okay, where this is the center with 126, and there's an angle here which is 33 degrees. We have B, we have C, we have O, we have D, we have A. Okay, so they want angle ADC, angle ADC, which is ADC. So there are many ways to kill a rat. These questions, they're not difficult to solve, okay, but you have to think. Without proper thinking, you won't be able to get the property to use. Okay, so how can you find ADC, which is simply this angle? Okay, we have been given this, but want to find this. How can we get that? Okay, so there are many ways to kill a rat. Okay, one of the ways is you can see this to be a cyclic quadrilateral, which simply means a four-cornered shape inside the circle where all the four corners are on the circumference of the circle. So for a quadrilateral, we know that this angle and this angle, when you add them, should give you 180, right? We're looking for this. This we can get from this. Angle at the center is twice angle at the circumference, right? Therefore, angle A, which is the angle at the circumference, ABC, is equal to angle at the center, which is AOC, divided by 2. So AOC, it's 126, divided by 2. So 12 divided by 2, 6. 6 divided by 2, 3. So it's 63 degrees. Okay, so angle ABC is 63 degrees. Now these 63 degrees and these are opposite angles of a cyclic quadrilateral, meaning that if you add them, they should give you 180. Or in the faster way, you can say angle ADC is equal to 180 degrees minus this one, which is 63 degrees. Okay, 180 minus 63. Okay, so your answer will be 180 minus 63. Okay, so 180 minus 63, it's simply, I'm doing it like paper one. I won't just say the answer for some of those who may struggle here. So we use the odd method. Others can do it in the head, of course, which is okay. 10 minus 3, 7. 7 minus 6, 1. 1. So the answer is 117 degrees. Okay, so this angle is 117 degrees. Okay, next, OCD. OCD. Okay, so OCD, it's this angle here. Okay, so now this is something new. What we're going to do is something new, that is, it's not part of the normal circle properties. Okay, like I said, there are many ways to kill a rat. Maybe you can think of the other way, but the answer should be the same. Okay, oh, okay, so here we have 126 degrees, here we have 33 degrees. Okay, so we're talking about OCD. OCD, right? So this is OCD. Now, these arrows are not decorations. They are not here for decorations. They are telling us that this line is parallel to this line. If lines are parallel, it means they can go and go without meeting. Though according to my handwriting or my drawing, they are not parallel, right? But what does it tell you about parallel? Remember, for those in my class, you remember the Z. property, okay, that we use on bearing. That comes from two lines which are parallel. Then we say this angle and this angle are equal, right? So, meaning that if you continue this line and you continue this line, okay, this angle which is formed here and this angle are equal. So these are not for decorations. Whenever they put such things like this or those lines like this, they're not for decorations. They mean something, okay, where those lines like this, they mean that the sides are equal. And if they're arrows, they mean that the two lines with arrows are parallel. So if we can find this, it means we found this. How can we get this? Think of it. We have this angle here. How can we get this? This is a straight line. Angles on a straight line add up to 180. That is, this plus this should give you 180, right? So this angle we're looking for, this angle, we're going to call it x. It's 180 minus this one, which is 126. Okay, when you do your calculation, you're going to get 54 degrees. 180 minus 126. Okay, so this angle here is 54 degrees, meaning this one is also 54 degrees. Okay, let's go to the last question. So the last question says BAO. So again, we have our circle with our diagram like this, like this. So we have BADOC. Here we have 33 degrees, right? Here we have 126 degrees. All right, so these are parallel. So they want us to find BAO, this angle here. How can you get BAO? Okay, so like I keep on saying, there are many ways to cure that. Then another thing, as you are solving such, as you are solving circle theorem, is the angles that you have found. You have to remember them. Like here, we have an angle here, and where else? Here we have an angle. Okay, right? Yeah, these are the angles we have found. Okay, so I think we also know this. So now there are different ways to cure that, but here we're going to use some strange property in that it's not part of circle geometry. So to say, the property is simple. It says, given any quadrilateral, a quadrilateral is a shape that has four corners. This plus this plus this plus this should give you 360. Okay, well, maybe it is part of circle geometry, but no, it's just part of geometry. Okay, any four-cornered shape, not this one, any four-cornered shape, this plus this plus this plus this, they should give you 360. When you add the angles inside any four-cornered shape, they should give you 360. Just like the way we say that given a triangle, a three-cornered shape, if you add the three corners, they should give you 180. For quadrilateral, it's 360. Therefore, to find this, we need to know this, and know this. Okay, we already know this, we already know this. This we can get it by doing, remember, a full circle is 360. So 360 minus this part will remain with this. So 360 minus 127, which is 5 here, 10, 10 minus 7, 3, 5 minus 2, 3, 3 minus 1, 2. So 233. So this 233 and this angle 33 and this angle here, we're going to remove them from 360. So our angle here, which is BAO, is going to be 360 minus 233 minus 33 minus this angle we had found 126 divided by 263, so minus 63. So it's going to give us 360. So we can add these three first, right? Or we can write like this to avoid confusions. 360 minus open bracket 233 plus 33 plus 63. Okay, so from 360 we remove the total of this angle, and this angle. Okay, so we're going to get 30 as the answer. I know you can manage to calculate this. 233 plus 33, it will give you 266 plus 63. Is it 266? Let me see. Yeah, 266 plus 63, it will give you 263 plus 63, 266 I mean. So 266. Sorry, I feel like there's a number which is wrong. Let me pick my numbers again to avoid issues. So 233, we got it from 360 minus 127 here, right? Then we have 33 here. Then here we had, is this 127? No, it's not. That's why. Okay, let me just do this. It's 126. Sorry. Yeah. So BAO is equal to 360 minus, so we have we have this angle here, hope you can see, which is 360 minus 126. 360 minus 126, okay, which is 5, 10, 10 minus 6, 4, 5 minus 2, 3, 3 minus 1, 2, so 234, plus the 33 here, plus here we had gotten 63, so it will be 360 minus 234 plus 33. It's going to be first we can just say 3 plus 3 like this, 3 plus 3 plus 4, or you can add somewhere. You're going to get 10, which is 0 carry 1, 6 plus 3, 9 plus 3, 12 plus 1, 13, 3 carry 1, then 2 plus the 1 that what carried, it's 130. You can do them in whatever way you're comfortable with. 360 minus 130, it's going to be 30 degrees. Okay. Oh, sorry. Okay, going to bearing now. So the diagram below shows 3 points, J, K, and L on level ground. K is due east of J. So when they say K is due east of J, it means K and J are like this, such that when you draw a compass on J, the east of J, that's where K is. In short, this line which connects J and K is east of J. Okay, giving you an insight of doing some 90 degrees there. Okay, so they want the bearing of K from L. K from L. So let me draw the diagram so that I can also mention some mistakes that most people make. So this is 70 degrees. This is 30 degrees. So they want the bearing of K from L, which simply means if you're on L, then you are facing north. How can you turn to face K? You turn like this, then you'll be facing K. So don't be deceived thinking that this is north. This is not, this is north, this is not north. It could have been north if they had said J is due north of L. It means this line is north. But if they have not said that, regardless of what your eyes are telling you, it's not north. Okay, that's why I've deliberately tilted the line to be like this. Okay. With that, how do we find this? So this is simple from what we've discussed so far. You think of the Z. Okay, or let me start again. First, I always recommend you draw a compass where you're standing. In this case, we have this compass here. Okay, so we want this. So the compass tells us that this is 90 degrees. So from 90, if we can remove this, we'll remain with our angle, right? For those who cannot picture it, let me use the colors to help you see. This is 90. Okay, what we're looking for is from here to here, like so. Okay, this is what we're looking for. So to get the green part, all we need is the blue part to remove it from 90. We know the blue part, this one. We remove it from 90, we remain with the green part, which is the angle, right? So how can we know the blue part? The Z. So this is 30 degrees, and 90 minus 30, it is 60 degrees. But bearing, you will have to write 3 digits. This is the bearing of K from L. Question number 2, J from L. So to face J when you are on L, facing the north, you have to turn like this. Then you are facing J. So from here to here, it's 90. From here to here, it's 180. From here to here, it's 270. Okay, so from 90, 180, 270. 90 plus 90 plus 90. So what is needed is just this last part. It means our angle is complete. So how can we get this yellow part? Okay, again, you invoke the Z. If this is 70, this must be 70. So this is 70 degrees as well. Therefore, 270, which we got after doing 90 plus 90 plus 90, then plus 70, which is going to give us 350. Sorry, not 350, 340. Sorry, phone calls. So it's going to give us 340 degrees. Okay. Sorry for that. We continue. Now we go to a must get question. Function, it's a must. You have to get it. So the question is saying, given that fx is equal to x plus 9, I think, over 2, and gx is equal to x minus 2. Okay, I can't see clearly here. I don't want to go and check the actual paper, but the understanding is going to be the same. So the first question is find function inverse of x. So there are many ways of finding, okay, there are 2 ways maybe of finding function inverse of x. The first is what I'm going to do here. It's the shortest and reduces confusion. So on this, make x subject. That's all. So you can put 1 here. You do cross multiply. It's going to be 2f inverse of x. Then this side you have x plus 9. Then you can bring 9 this side. It will be 2f inverse of x minus 9. And you remain with x here. You can rewrite this with x now on this side, 2 f inverse of x minus 9. Okay, so now with this, the last part is this, you write it as f inverse of x equals this side, you copy it the way it is, but where there's f inverse of x, you put x. So they have just exchanged position. Okay, 2x minus 9. So what we've done is, in this expression, x, we have okay, x and this, they have exchanged. Okay, x has become this and this has become x. That's what we have here. Okay, as you can see, x has become this and this has become x. It means you are done. Okay, number B, fgx. So our fx was x plus 9 over 2. Our gx was x minus 2. So fgx, what it simply means is you get the expression for x, but where there's x, you put this. Okay, so we are saying that the expression for x starts with x, but where there's x, they want us to put g plus 9 over 2. Now g, we know it's x minus 2 plus 9 over 2. So x negative 2 plus 9 is plus 7 over 2. So this is your fgx. Okay, so now the next question was saying fg negative 5. So the expression that you have found, the fgx, which was fgx, it was x plus 7 over 2. So they want now fg5. So where there's x, they have put 5. So that's what we do. Where there's x, we put 5. 5 plus 7, 12 divided by 2, which is 6. Was it 5 or negative 5? I think it's negative 5, sorry. Negative 5, so negative 5. Negative 5 plus 7, it will give us negative 2. So the final answer will be 1. Negative 1. Negative 2 divided by 2, negative 1. Going to the next question. Find the equation of a straight line which is perpendicular to the line. Okay, so they have given us this line, 2y minus x equals 3. So they are saying this line, 2y minus x equals 3, it's like this. There's a line which is perpendicular to it like this at 90 degrees. So they want us to find the equation of this one. So now the property of these two lines is they share a property that connects their gradients. That is, the gradient of the line we want, we're going to call it ML, is equal to negative 1 over the gradient of the given line. We're going to call it P. Okay, because the two lines are perpendicular. So we're looking for this. Okay, or we can say we're looking for the perpendicular line, so we call it P, and the given line we just call it L, whatever you want. Okay, so with that, we need to find the gradient of this. So we have to compare this with the standard equation of a straight line, which is y is equal to mx plus 3. Okay, sorry, plus c. So the m is the gradient. So we have to make y subject here so that it looks like this. Okay, so we make y subject by taking x to the right. So it will be like this. 3 is positive, so it's just positive 3, right? 3 is positive, so we introduce the positive. Okay, x has just come, it was negative x. came here, it became positive x, but there's positive 3 already. Okay, so you divide by 2 everything by 2, this and this goes, so your y is equal to x over 2 plus 3 over 2. So from here you can tell that your gradient is the coefficient of this. The coefficient of this means the number in front of x here, which is the invisible 1 over the 2 also. Okay, so the number part of this term is our gradient. Okay, because if you look at this, there's x, the rest is called m, so our gradient is 1 over 2. That's the gradient of the given line. Now to find the gradient of the perpendicular line, we say gradient of the perpendicular line is equal to negative 1 over 2. This 1 over 2 is the gradient of the given line. In short, all you have to do is this number, you take 2 on top, 1 on the bottom. That's how to simplify this part. You just concentrate on the gradient, the 2 you take it up, the 1 you bring it down, like so, 2 over 1, and the negative will be there, which is simply negative 2, because 2 divided by 1 is negative 2. Okay, so this is the gradient. So let me say that again. To simplify this expression, okay, just think of this gradient, divest the numbers, 2 on top, 1 on the bottom. Okay, that's what you get after simplifying this with a negative. Okay, so it gave us this, which became this. So this is the gradient of the line we're interested in. Now that we know the gradient of the line we're interested in, from here you can use either of the two methods that I taught you on that question where we are finding the equation of a straight line. Okay, since our gradient is negative 2, I'll use the method that I don't like, but it's fast, which says x minus x1 m y minus y1. So I've been given a point which is negative 4, 1. Okay, so it's going to be x minus x1 is negative 4. So put it in brackets. Okay, don't make a mistake of forgetting to put it in brackets. Negative numbers, be careful with them. Whenever you want to put them, to substitute a letter for a number, put it in brackets. You can make mistakes if you don't. So m is negative 2. So this negative 2 also put it in brackets. It can give you problems. So y minus y1, it's 1. Okay, so it's going to be x, negative times negative, plus 4 in brackets, negative 2 here. So y minus 1. So negative 2 times x, negative 2x. Negative 2 times 4, negative 8. Y minus 1. You can bring negative 1 this side. Negative 2x minus 8 plus 1 remain with y. Okay, so negative 2x, negative 8 plus 1, negative 7 is equal to y. Okay, so the final answer will be y is equal to negative 2x, negative 7. I've run out of space, but the final answer will be something like this. Y is equal to negative 2x, negative 7. This is our final answer. Sorry, the calls are non-stop. I don't know what I've done. Okay, next question. In the answer below is an incomplete flowchart for calculating the surface area, the curved surface area. Okay, let me just answer them. So in the enter here, you have to write enter or input. Enter. Okay, now for you to answer this question, you need to remember from mensuration the formula for the curved surface area, which is 2 pi RH. They can bring any formula. Okay, but by the time you're going to write an exam, it means you have all the formulas in your head. Okay, so enter here is to write enter. So now enter, you will write the letters on the right side. In this case, it's just R and H. These are only letters. This is not a letter. It's not on ABCD. It's a number. called pi. So enter RH. Then here you write the formula, this formula the way it is. Okay, area is equal to 2. If you want, you can put star to show times pi times r times h. It means the job is done. The figure below shows a parallelogram with center O. Describe fully the symmetry of the parallelogram about the center O. So when it comes to line symmetry, this figure has zero lines of symmetry. 0 lines of symmetry. A parallelogram has 0 lines of symmetry. You cannot divide it so that it produces 2 mirror images. No. When you fold this, it won't be the same as this side, as this side. No. Okay. Rotation symmetry. It has a rotation symmetry of order 2. Okay, you can rotate it such that this part comes here to look the same, and again you can rotate it like this. So you can rotate it such that this part moves and comes here. That's one. Sorry, this part moves and comes here. That's one. Okay, you can also rotate it such that this part moves and comes back to let me do this. It moves like this and comes back to where it was, 2. So it has a rotation symmetry of order 2 and 0 lines of symmetry. Question 18. It is given that y varies directly as 2x and inversely. So this is variation. Okay, so it is given that y varies directly as 2x and inversely as z squared. So as you are reading the English, you should be able to also translate it into numbers, which simply means y is equal to k 2x over z squared. So they want you to find the value of k, the constant of variation. So they have given us y as 4, k 2, and x as 8. Well, z is 2 squared. So we start solving for k. 4 is going to be k. 2 times 8, 16. Okay, 2 squared, 4. Okay, you can do cross multiply. 4 times 4, it will give you 16, equals k times 16 to be 16k. So you can divide by 16, you can divide by 16. This and this will go. Then we'll remain with k this side. I'm writing on top. 16 divided by 16, it's 1. So our k is 1. Value of y when x. Okay, so we write the equation connecting all of them. So we have this, 2x over z squared, right? Because k is 1, so we won't write anything here. It's invisible. Okay, or should I say 1 times 2, it will be 2, so there's no need to write the k. Okay, so they want the value of y when x is 27 and z is 3 power 2, right? So 2 times 27, 54. 3 squared, 9. Okay, 9 into 54. It's going to go there. Is it 7 times or 8 times? Is it 9, 18, 27, 36, 40, 9, 18, 27, 36, 45, 54, 6 times. Okay, so that's your y. C, value of z when x is 24 and y is equal to 3. So y is equal to 2x over z squared. So y is 3. 2x is 24. Z is what they want. So be careful with this question because you may not get the full marks if you haven't done it properly. So it's going to be 3. 2 times 24, it's going to be 48 z squared. Then you can do cross multiply. You're going to have 3 z squared equals 48. You can divide both sides by 3. This and this will go. So you remain with z squared is equal to 48 divided by 3. It will give you 16. Okay. So now the last part is the one that I want you to pay attention to. Okay. So z squared is equal to 16. So to get rid of z, you do square root, you do square root. This and this will cancel. You remain with z. Now, square root of any number has two answers. There is a positive number and a negative number. So square root of 16 is 4 and negative 4. If you want, you can get your calculator. You do 4 times positive 4 times positive 4. It will give you positive 16. And negative 4 times negative 4 will give you 16. We go to 19, integration. So we've been given 6x squared minus 2x plus 7, right? They want us to integrate with respect to x. Okay, so integrating, the formula is simple. If you have been given a number called a, x, and power, to integrate, the first step is you add a 1 here. So to the power, you add the 1. Then you divide everything by the new power, n plus 1. Therefore, we're going to have 6x, 2 plus 1, 3 over 3, minus 2x. This one has an invisible 1 here. So 1 plus 1, 2 over 2, plus 7. The procedure, what I've told you, this rule is the same, but there's no need to learn it. What you have to learn is, in integration, if you integrate a number that doesn't have a letter, or should I say a variable, you just put x. So integrating 100 gives you 100x. 100x. Integrating 3000 give you 3000x. Okay, so integrating a number that has no letter introduces a letter at the end of the number. So the next job is now to simplify. 3 here, 1, 3 here, 2. So you have 2x power 3. 2 here, 2 here. So you have minus x squared plus 7x plus c. Don't forget the c. Most forget the c. Don't forget the c. Okay, after doing everything, add the c. That's the rule. And there's a good reason for that, which we may not need to go into details now. So the areas of two similar cylinders are this and that, respectively. If the height, so for those in my students, for those in my class, oh, I'm tired. Should I stop? Maybe continue later. Okay, let me see. So for those in my class, you know the simple analogy that I give. Okay, there are 3 things we deal with when it comes to similarity. There is similar areas, there is similar sides. Sides include height, radius, diameters, length, breadth, width. Okay, and there is similar volumes. So I always say you can think of areas as copper belt, CB. You can think of sides as Lusac. You can think of the volumes as I will say, Mazabuka. Okay, so to move from area to sides, you have to do square root. Then to go back from sides to area, you have to do power 2. To move from sides to volumes, you have to do cube roots. To move from volume to sides, you have to do power 3. You cannot move direct from volume to area, okay, or area to volume. Okay, you have to pass through sides. Okay, let's apply this concept now. So the area of two similar cylinders are 64 and 36. So they've given us the areas of the cylinders, which are 64 and 36. Now they want us to find the heights. So we need to move from here, where we're talking about areas, to here, where we should be talking about sides. How do we move from areas to sides? We do square root, meaning we have to square root 64 and square root 36. Square root of 64 is 8 and square root of 36 is 6. So on the sides, that's where we are now. Now we can start solving, since we're looking for a height, or should I say the height of the smaller cylinder. So according to this, we can tell that this 8 represents the bigger cylinder and this represents the smaller cylinder, right? So now I'm going to erase everything. I'll pick it up. Since now we have the actual ratios to use, I'll pick it up from here because I want to share more insight. So we have the big cylinder and the small cylinder having the ratio 8 to 6. So now, if you have the ratios, it's okay to reduce them. Why should you reduce? To have smaller numbers to work with. So it's okay. You can use this the way they are, or you can reduce 2 here 4, 2 here 3. Is there any number that goes into 4 and 3? No. So now these are the smallest ratios. Okay. Now that you have the smallest ratios, you can start solving. You have small numbers. They will give you the same answer, even if you use the big ones, but without problems. Okay, this is what makes paper 1. You understand these concepts, you are good in paper 1. So they want us to find the height of the larger cylinder. So we don't know the height. We're going to put x when, they've given us the height of the larger cylinder as 30. They want the height of the smaller cylinder. So we don't know, put x. We do cross multiply. 4 times x, 4x. 30 times 3, 90. Divided by 4, divided by 4, right? So x is going to be equal to 2 here. 4 here, 1. 4 into 9, they are there 2 times, remainder 1. 4 into 10 is there 5, remainder 2. Okay, so we're going to have remainder 2 over denominator never changes. Okay, which is the same as 25. 2 here, 1, 2 here, 2. So 1 over 2 centimeters. You have seen what I've done. 4 here, 1. 4 into 90 is 25 times. Remainder 2 over 4. Okay, I know you like putting in decimals. Maybe you could have tempted to put in decimals like this, 90 over 4. Then you do 4 into, maybe you can even do this, 2 here, 2 here, 45, right? 2 into 45, 2 into 4, 2, 2 into 5, 2, point. You do all that. That's a waste of time in paper 1. Rule of paper 1. The other rule of paper 1 is do your best not to work with decimal points. Work with fractions. Paper 2 is designed for fractions. If you work with decimals, they are going to take your time. They are difficult to solve. Okay? It's opposite of paper 2. Paper 2, you have to work with decimals. Okay? Paper 1, you have to work with fractions. Okay? Decimals are better in paper 2. Fractions are better in paper 1. Okay? So you could have done like this, 2 into 45. 2 into 45, 2 into 4, 2 into 5. It's 2, right? Is it? Yeah, it's 2. Yeah, it's 2. Remainder 1. 2 into 1, it can't. 0.0. 2 into 10, 22.5, right? But the faster method is, you can reduce, yes. 2 here, 2. 2 here, 45. So you have 45 over 2, right? 2 into 4, 2. 2 into 5, 2. Remainder 1 over 2. We are done. Centimeters. Don't forget the golden rules. Question 20. In the diagram below, we have this. So this was one of the trickiest questions on trig. Okay. So they want you to find DAC. this, okay? Tan DAC. We know tan, according to SOHCAHTOA, is opposite over adjacent. So opposite of this one, this is opposite, adjacent, this is adjacent. So for us to find tan ADC, we need to know the opposite and the adjacent. Without them, we can't. Okay, so let's start with this. Okay, now be careful. This is the opposite. This is the adjacent to this triangle and this angle here, but not to this triangle on the bottom. The triangle on the bottom, this is the hypotenuse. So we're going to say AC squared is equal to 3 squared plus 4 squared, right? Which is 3 squared 9 plus 4 squared 16, which is 25, right? So we're going to do square root. So AC is equal to 5, right? That's step 1. So for my students who are writing this as more like a test, most of you did this part. So most of you ended here and did some manipulation for finding tan, which were wrong. So this is 5. Next, we have to find this. Now, this is 90 degrees. So this is the hypotenuse. Okay, so to find this, we have to do DC squared, hypotenuse, which is 13 squared, minus this one, 5 squared. 13 squared, 169, minus 5 squared, 25. Okay, 169 minus 25, it has to be 144. Okay, so you become faster with this when you practice the powers. This exercise was is done in grade 9. They will teach you powers from squares from 1 to I think 20, 25. So you have to know 25 times 25, you get what? 24 times 24, you get what? 20 times 20, you get what? Okay, it's an important exercise for faster calculations. Okay, so 169 minus 25 is 144. Okay, then square root. This is equal to 12 because 12 squared is 144. Okay, let me just check that. For those who are doubting, 2 times 2 is 4, 2 times 1 is 2, 0. 1 times 2, 2, 1 times 1, 1. So when you add 144, right? So we have a 5 here and a 12 here. So we want this. So tan DAC, tan DAC, this one, which is this, tan opposite over adjacent. Opposite, which is 12, over adjacent, which is 5. Okay, remember there's a 5 here and there's 12 here. So tan DAC is 12 over 5. So this is the answer we put here, 12 over 5. Write 3 inequalities that define the unshaded region R on the diagram below. So you start with the simplest. The simplest is vertical lines and horizontal lines. In this case, we won't have a vertical line. So this vertical line passes at this point 2, okay? And the shading is on the left, meaning we're interested on the right. Right is good, right is great, right? So we have X, because the line cuts the x-axis at 2, greater. Right is great. And top is great because God is in the heavens here. So top is great, right is great. Okay, and left is less, bottom is less. Okay, so now if you pay attention to this, it is dotted like this. Since it's dotted, you don't have to put the equal to symbol here. Okay, so it is just this. That's the first one. The second one, it's this and this. Okay, I'll start with the second easiest, which is this. Why is this the second easiest? Because we can see where it cuts the y-axis, which is 8. This point here is 0,8. So it's cutting the y-axis at 8, meaning that we don't have much to solve, but we still have some dues to pay. That is, we have to find the gradient. So the job is to find this. These are straight lines, so their equations are like this. So the first is to find m. So m is equal to y2 minus y1 over x2 minus x1. So y2, the points we have 0, 8 and is that 4,4? 8,4. Okay. So y2, so x1, y1, x2, y2. So y2 is 4 minus y1, 8 over x2 is 8 minus x1, 0. 4 minus 8, negative 4. 8 minus 0, 8. So negative 4 divided by 8 is negative 1 over 2, right? So our gradient is negative 1 over 2. When I'm fast, it means that I trust that you can get that part, right? So this is our m. Okay, so now we have y is equal to mx plus c. Now, where there's m, we put our negative 1 over 2, x plus c. Now, c we know it's 8. C means where it cuts the y-axis. Okay, so it's 8. Okay, so next is what symbol are we going to put here? So here we have this situation. Our region of interest is this. Do you think this is greater or less? You can use your eyes or you can use analysis. According to my eyes, this is less. It looks like it's bottom and left. Therefore, it's going to be less. And since it's a solid line, it means equal to. When it's a solid line, then this has to be indicated. So this is the second equation. The third is the difficult one now, because we don't know where it's cutting the y-axis. Okay, and also there's 8,4 here. Here they have just put 2, meaning it's 2, 0, because it is on the x-axis. On the x-axis, y is always 0, so it's 2, 0. So we start m is equal to y2 minus y1, same steps as before, x2 minus x1. So y2 is we have 8,4, and here we have 2, 0. Oh, okay, I've written it already. So this is x1, y1. Doesn't matter which one you can call x1 and y1, doesn't matter. But the first numbers are the x, the second numbers are the y. Okay, so y2 minus y1, we have 0 as y2 minus 4 over x2, it's 2 minus 8. So 0 minus 4, negative 4. 2 minus 8, negative 6. So negative and negative cancel. 2 here, it's going to be 2. 2 here, it's going to be 3. So 2 over 3 is our gradient. Therefore, our m is 2 over 3. Now, to find the equation, we use that formula which I don't like. X minus x1, m, y minus y1. Okay, for those ones who like my formula, the other one, you can use that, you get the same answer. So x, we pick endpoint here. Which one should we pick? 8,4, 2,0. 2,0 is better. Anything that has 0 is better. Okay, so we're going to have x minus x1 is 2, m is 2 over 3, y minus y1 is 0, 0 y1. So here we're going to have 2 over 3 times x. It's going to be 2x over 3. 2 over 3 times negative 2. For those who may have changes, it simply means this. Any number without a fraction has an invisible, any number which is not a fraction has an invisible over 1. That's a rule of mathematics. So negative 2 times 2, negative 4. 1 times 3, it's going to be 3. Okay, that's how to deal with multiplying a number that is not a fraction with a fraction. You introduce over 1, and then you multiply everything on top with everything on the bottom to give you this. Y minus 0 is y, so meaning we can write it as y 2x over 3 minus 4 over 3. We need to put a symbol here. So as you can see, this looks like top, right? So it's going to be greater or equal to. It means you have gotten your 5 marks. So this takes time, so you need to learn how to practice. Okay, you need to practice a lot, in short. And you have to be very fast because no one is going to care about your method. No one cares. Okay. Okay, so almost getting done. Okay, so question 22a, given that root 2 is equal to 2 power x. So root 2 simply means 2, 1 over 2. Remember those of indices. Laws of indices say when you have this situation, the number on the bottom turns into this. Okay, if there was a 3 here, then you could have put a 3 here. If there was a 4, you could have put a 4 here. But if there is nothing, the rules of mathematics say that there is an invisible 2, which appears here. So it's equal to 2 power x. So if the bases are same, this should be the same as this, which in mathematics we say this should be the same as this. It means we have found our x. Okay, question 22b. The diagram below shows this y is equal to negative x plus 2, x minus 5. So this cuts the x-axis at A and B. Find the coordinates of points A and B. So where it cuts the x-axis, it means y value is 0. Remember that question of from doing for inequalities where the line like this, it was passing here, it was 2. We said 2, 0 because y is always 0. You see how beautiful mathematics is, everything connected. So it means y should be 0, which simply means this whole thing is the same as 0 is equal to negative x plus 2, x minus 5. Okay, so to know these coordinates, we just have to solve how this should be equal to this. I'm doing this deliberately because most of you like putting 0 on the right, but there's no difference. Okay, and this should be equal to this. Okay, so you can take 2 this side, it becomes negative 2 equals negative x. You can divide by negative 1, divide by negative 1. This and this goes, this and this goes. You have 2 is equal to x. Here you can take negative 5 this side, it becomes positive 5x. So x is 5, x is 2. But the question says find the coordinates. So coordinates must be this comma this, this comma this. So here and here. And also you have to say that A is this. A, for example, A seems between 2 and 5. A should be 2 because 2 is smaller than 5, and B should be 5 because this seems to be away from 0. Okay, so this is bigger than this. Therefore, A should be 2, 0, and B should be 5, 0. Remember, the x values are always the first ones. The y values, the zeros, are the second ones. So A 2, 0, B 5, 0. Maximum value of y. Maximum value of y, for you to find the maximum value of y, you need to expand this. Okay, so it's going to be y is equal to, when you expand, okay, let me just write it, negative x plus 2, x minus 5. So when you expand, it's going to be negative x times x, negative x squared. There are different ways in which you can expand, but there's a method that I've copied from one of my students. It's very good. Okay, so negative x times x, negative x squared. Then from here she goes to this number times x. 2 times x is going to be, is this how she does it? No. So the first is she multiplies this times everything here. So negative x times x, negative x squared, negative x times negative 5, it's positive 5x. Then next she goes now to this 2 times x plus 2x. Wait, this is how I also solve. So I don't know why I thought her method was better. 2 times negative 5, it's going to be negative 10. Okay, so it's going to be negative x squared. 5x plus 2x is going to be 7x. okay, minus 10. Okay, so here your A is -1, your B is 7, your C is -10, right? Remember, the standard equation is ax squared plus bx plus c. So if you compare with this, your A is the coefficient of x squared, which is -1. Your B is the coefficient of the term on the middle, which is 7. Your C is the last number, -10, right? So that's our A, our B, and our C. Now, from here, we just have to use the formula. There are two formulas. The first one is called equation of axis of symmetry, which is like this. The second one is called maximum point or minimum point, right? So it says y is equal to negative b squared minus 4ac over 4a. Okay, so it's negative b squared 7 squared minus 4a is -1, c it's -10 over 4 times -1, right? This one you can solve. The teacher is tired, so I'm not going to solve this any further. Okay, let me rest a bit. Let me drink some water. Okay, so let's continue solving. Okay, so we have 7 squared minus 4, -1, -10. Okay, so we have 7 squared minus 4, -1, -10 over 4 times -1, I think. So negative in front. -7 squared is 49. -4 times -1, 4 times -10, it's positive 40 over -4. -49 plus 40, it's going to be 89 over -4, if I've not made any mistake. Yeah, so here negative and negative will cancel, so you remain with 89 over 4. You can do 4 into 8, it's going to be 2. 4 into 9, 2. Remainder 1 over 4. Okay, this is your maximum point. I'm not sure if I'm accurate in the mathematics, because I think I got a bit tired there. Yeah. So, but you get the idea on how to solve it. There are different methods. There's also one fun method that I saw from one of my students in the old days. It used to work, but it was fake. Okay, so like 2 and 5, she could just add the 2 and divide by 2. So 2 plus 5 is 7 divided by 2. So 7, actually it's correct. Yeah. If you think about it, it's correct. Anyway, yeah, it's correct. Also, let me say it now. So you just have to pick the x value of here and here of the 2 points. In this case, 2 and 5. You add them, then you divide by 2. It will give you 7 over 2, right? So this is the first stage. The second stage, you put 7 over 2 in your equation, like so. Y -7 over 2 plus 2 over, brackets, then 7 over 2 minus 5. Okay, then you start solving. But again, this can be a bit, let me see, is that other approach better? Because here you have to solve fractions. You introduce a 1, then it's going to be 2 and 1 common denominator is 2. 2 into 2, 1 times -7 plus 1 into 2, 2 times 2, 4. Okay, in brackets, and this side as well, 2 into 2, 1 times 7, 7, minus 1 into 2, 2 times 5, 10. Okay, then you're going to have -7 plus 4, it will be -3 over 2, and 7 minus 10, it will be -3 over 2. So it's like this. Let me pick it up from here. Okay, please, when I erase, you can be pausing the video, you copy what you want. So -3 times -3, it's the 27 over 4, right? And 2 times 2, 4, right? So 4 into 27, how many times does 4 go into 27? It's 4 times 6 is 24, right? So it's 6, remainder 3 over 4. So this, I think this is the correct one. The other one, I think I was a bit tired, but yeah, I'll go through just to verify. Yeah, but this approach is simpler than the one for the formula. But if you are used, it's okay. So here you pick the x value and the x value, then you divide them by 2. That is 2 plus 5 divided by 2. You get 7 over 2. Don't go to points. Then you use 7 over 2 now in the original equation, okay? Or in that equation which you had expanded, okay? You put, where there's x, you put 7 over 2. You find the value of y. That's your maximum point. Last question, finally. This one I'll do it with a lot of energy to act as if I'm not tired. So find the acceleration of the object when time is 3. So 3 is between 0 and 5. So the acceleration is here. So the biggest mistake lots of students make is they want to use 3 in the calculation. Okay, acceleration here is the same. So it doesn't matter which numbers you use. If you use 3, for example, you should be sure that there's a corresponding time, but there's nothing here. So there's no way you can use 3. But you can use 0 because 0 has a corresponding time, which is 4. And you can use 5 because 5 has a corresponding time, which is 24. Okay, so you can say acceleration is equal to v minus u over t. V is 24 minus u, which is 4, time, which is 5. So it's 20 over 5. 20 divided by 5, it's 4 meters per second squared. Okay, so don't forget this. It's a common trick by ECZ. B, given that the object decelerates at 2 meters per second squared, find the value of t. Okay, also this one, deceleration is equal to u minus v over t. Remember, acceleration, I said v minus u over t. Deceleration, you just reverse. This goes here, this goes here. U minus v. But again, there are different ways of solving deceleration. You can also use negative acceleration, v minus u over t. Okay, but make sure that the method you use is valid. Me, I like this one. So deceleration, they've said is 2. Okay, initial velocity is 24. Final velocity, it's 0. Time, that's the mistake that most students make. They take time as t. Time is not t. Time is from 10 to t, which is t minus 10. The difference here, that's the time we're looking for. Okay, so it's 2, 24, t minus 10. Then you have to do cross multiply over 1. Okay, so when you do cross multiply, I'll write on top, it's going to be 2 times t, 2t. 2 times negative 10, negative 20 equals 24. We can take 20 the other side, it becomes 2t is equal to 24 plus 20. So 2t will be, in this case, this time let me use a different color. 2t is going to be equal to 24 minus 20 is 4. Am I doing the correct thing? Or I'm losing focus. So we did cross multiply 2t negative 20. So 2t minus 20 is equal to 24. So when 20 comes this side, it becomes plus. So I wanted to write plus, but I did not write properly. So it's supposed to be plus, so that it gives us 44. So divided by 2, divided by 2. This goes, our t is equal to 44 divided by 2, 22 seconds. Okay, so the mistake is here. So here we have 22 seconds. Last, calculate the average speed of the object in the first 10 seconds of the journey. So the average speed of the entire object. So what shapes can we create here? We can see a trapezium here and also another small trapezium, this one. Okay. I've just realized that I gave one of my students the correct answer for something wrong. I think it's wrong. I'll check. You know yourself. Okay, so it has to be 2 trapeziums. So area is equal to, or distance, which uses the formula for area, is equal to, so distance 1 plus distance 2. Distance 1 for this first trapezium is half A plus B H, plus for the second one, half A plus B H as well. Okay, so half for the first one, A is the distance from here to here, which is 24, plus B is the distance from 0 to 4. Height is from 0 to 5 here, plus again half for the big one now. A is from here to here, 5 to 22. 22 minus 5 is 17, right? This is 22, this is 5. 22 minus 5 is 17, plus B is from here to here, which is 5 to 10, which is 5. Height is from here to here, which is 24. So we're going to have 1 over 2, 24 plus 4, 28, 5, plus 1 over 2, 17 plus 5, it's going to be 22. 5, right? So I'm continuing it from here so that you can see all the manipulation. How come we have, okay, I thought it was a mistake. We have 5 there, and so, okay, I see I made a mistake. It's supposed to be 24 here, right? Yeah. So we have half 22, 5, plus half 24. Let me see. For the big one, half A plus B, A is 5 plus 5 is 22, 24, right? So we can do, then for the small one, half A plus B, 4 plus, for the small one is 28, like half A plus B, half A plus B H. So it's half A from here to here, which is 24, plus B 0 to 4, which is 4, right? So 24 plus 4 here, it's supposed to be 28. Okay, now we can do 2 here 1, 2 here 14, okay, and 2 here 1, 2 here 12. Okay, so we remain with 14 brackets 5 plus 22, 12. Okay, so what has remained is just to multiply. Okay, so 5 times 14, 20, 0 carry 2, 5 times 1, 5 plus 2, 70, plus 22 times 12, 22 times 12, you know what to do. 2 times 2, 4, 2 times 2, 4, then 0, 1 times 2, 2, 1 times 2, 2, so it will be 264. Then 264 plus 70 is going to be 334, is it? Yeah, 334 meters. So this is the total distance. You have to be very fast in solving this. No one cares about how neat it looks. No one cares about how step by step you are doing. No. So average speed is equal to 334 divided by 22, which is the total time, right? So you can reduce 2 here 11, 2 here 2 into 3 1, remainder 1, 2 into 13 6, remainder 1, 2 into 14 7, 11 into 167, 11 into 16 it's 1, remainder 5, 11 into 57 it's 5, remainder 2 over 11. This is your average speed, meters per second. See you in the next lesson.